Back everyone. So we will continue with chapter 16, the planar kinematics of a rigid body, and then we're dealing with the rotation about fixed axis. This is section 3. So now we'll be solving this problem, 1633. Here the problem says that we have a driving belt. So the driving belt is twisted so that the pulleys or pulley B rotates in the opposite direction to that of drive wheel A. So we have a pulley here at A connected via a belt to pulley B. And now, because of this configuration, if pulley A was rotating clockwise, then B will be rotating in the opposite direction, meaning it's rotating counterclockwise. Now, if the angular displacement of A was given as theta A equals 5t cubed plus 10t squared in radians, the question is asking us to determine the angular velocity and angular acceleration of B, so omega and alpha of pulley B at a time of 3 seconds. Here, what we know is that the radius of pulley A is 200 millimeters, and pulley B has a radius of 125 millimeters. So now, guys, as you can see, because these are attached to each other using a belt, and this belt is called a non-slip or non-slipping belt, meaning that if the angular acceleration if they were rotating in this direction as if they were like two gears and there's meshing between these two gears at some point, this indicates that the tangential acceleration and the tangential velocity at some point here must be equal. Okay, so let's move on. We need to find the angular velocity and acceleration of gear B. We have knowns here at gear A, or pulley, so these are pulleys, sorry. So we have, what we know here is that the angular displacement is given as 5t cubed plus 10t squared only at pulley A. So we have to move from pulley A to pulley B to get our information. So let's start solving. So this is problem 1633 in the PDF version or in the 14th version of our book. So we know that theta is given as 5t cubed plus 10t squared in radians. What should we find, or what we should find, are the angular velocity and the angular acceleration of pulley B at a time of 3 seconds. So if we have pulley A here and then we have pulley B here, so we have to move from A to B. This is A and this is B. We have to move from A to B. Now, because of this, I don't know, kind of connection, so basically now the tangential acceleration at A should be equal to the tangential acceleration at B. Also, the tangential velocities must be equal. So now, if theta A was given, then if we differentiate that with respect to time, we would get omega A. And if we differentiate it again, then we would get alpha A, right? So this is how we solve this problem. So now, let's start at A. Now at A, we have the angular velocity at A, or omega at A, is d theta at A with respect to time. So you just integrate that with respect to time. You integrate this equation, 5t cubed plus 10t squared. Then this would give you 15t squared plus, sorry, this is t squared, right? Plus 20t. This is radians per second. Now integrate that again, you will get the angular acceleration of pulley A. So this is d omega A over dt, which is d over dt of 15t squared plus 20t. And this should give us 30t plus 20 in radians per second squared. So this is our first equation, and this is the second one. Now, here you say that at what, 3 seconds, so omega A equals to 15 multiplied by 3 squared plus 20 multiplied by 3. This should give you 195 radians per second. And here at t equals 3 seconds, you would get alpha at pulley A is equal to 30 multiplied by 3 plus 20. So this is 110 radians per second squared. Now, since we know for a fact that wheels or pulleys or whatever, A and B, are connected by a non-slip belt. This acts as if there were two gears and they were a mesh point here. Then we know that the velocity of gear A at this point, for example, should equal to the velocity of gear B at that point. And we know for a fact that these velocities both are tangential. So here this is VA, here this is VB, right? So we know also that the velocity is related to the angular velocity using this equation, omega A RA equals to omega B RB. So we get that omega B equals, just solve for omega B equals omega A RA over RB. And this is equal to, so this is equal to 195 and 95 multiplied by the ratio between the two radii, 200 over 125 millimeters, and this is 310 radians per second. This is the first thing. This is the first thing the question is asking for. And also, we know that at this point also the accelerations, both of them, the tangential ones for both pulleys, are actually the same. So we get that the tangential acceleration of gear A should equal to that of or pulley. I keep saying gears, these are pulleys, sorry. So this is alpha A RA equals alpha B RB. So we should solve for the angular acceleration of pulley B. This is equal to the angular acceleration of pulley A multiplied by the ratio between the radii, RA over RB. We know this is 110 multiplied by the same ratio, 200 over 125, and this should yield a value of 176 radians per second squared, and we're done. So basically very simple ideas. The only thing that we need to know that whenever these two pulleys or gears or whatever, they have meshing, or for example they are connected together using a non-slip belt, then at this point they should have similar velocities and similar tangential accelerations. You carry out your integration or differentiation, and then you just go on. So that's it, I guess. In the next video we will solve something which is concerned with the Cartesian vector forms and notations. So that's it. Thank you.